Hi everyone, welcome back to my math teaching online. In this video, I will follow up with the previous video about the derivative of exponential function and logarithmic function. After this will be the last section of the chapter 7 in our first introduction to calculus course. Which is the application into the words problem to connect to the real life, how we solve the using derivative to solve the complicated word problems. And I am exciting. I cannot wait for the day I can publish my first course online that I am developing on my own. With all my experience of teaching high school students in the past, I served all the students in Langley, Surrey, in Hope, in Vancouver, in BC, British Columbia. I have built my experience of breaking down the concept in the small step to help you to be able to understand better in explaining the lesson to you. So I hope that you enjoy my teaching video, and I hope that I believe that this introduction to calculus course is very important, because regardless any major you are in, you want to be an X-ray technician or the psychologist in the university, they will ask you to at least have the first year introduction to calculus course. And my course will give you a smooth transition between high school level and university level or college. Anything you want to have it for your future. So stay tuned for the day I publish this course. And I hope that you are registered to my course, and you will see like how beneficial you gain from the course. I also upload some step-by-step solution, not all of them, because I believe that you still have to take your time to learn it and develop it, the skill on your own. But at least I give you some hints and the way to lead you, to guide you, how to perform the step in the shortest way of solution solving. So anyway, let me get right into the lesson. So I'm going to show you the differentiation of these functions. So number one, let's say you have a function, symbol function. Let's start by symbol, right? E to the 3 of x. Now, the formula said the derivative e to the x is just e to the x itself. So this will be e to the 3x by itself. But remember, by the chain rule, we have to differentiate the inner function, which is we time with 3. Now we can put the 3 in front and we can join them together, and that's it. So now question 2, let's say I give you a more complicated one. Let's say e to square root of x. So how are we going to take derivative of this function? Now, in my way, I will show you the shortcuts. So all what you do is rewrite this x in terms of rational power, and whatever it is, just the way it is, right? So e to the x, and you can put in rational power square root, the same thing, right? But then you have to derive the inner function, which is this. So we apply the power rule, we bring 2.5x, and we subtract minus 1 on top, right? Remember power rule, so that becomes this. Now we want to rearrange it a little bit, so that will be e to square root of x on the top, and I'm going to bring this x with the negative power down the level right here. Right, remember this is denominator, so stay at denominator. This is the top numerator, stay as numerator. So this is denominator, I bring it down here, and the x go down with it, and I put back into the square root. So that is the answer. A lot of teachers, or you will see in the textbook, they will split it in terms of e to the u, something like that. So I'm going to show you the way they did, right? So let's say you have a function y is e to square root of x. So they will say let u equal square root of x. And the same like x to the power 1/2. So then dy over du will be equal, okay, before you do this, sorry, you will put back into the u level, right? So they rewrite this in terms of u, so e to the u. So dy over du will be equal e to the u, right? And then they will say du over dx will be 1/2 x to minus 1/2. And therefore, I'm going to go to the other board now. Therefore, dy over dx will be equal dy over du times du over dx, which is the chain rule. And therefore, y prime equal dy over du is e to the u, but the u will put it back by square root of x times with 1/2 and x minus 1/2, the same like we just did it, right? So this is a long way when you do the substitution by u. And because I think that sometimes people do like this so that you guys understand better, because it's clearly you have to do the chain rule and you have to substitute and you have to do the derivative of this. Now, sometimes I use this substitution method as well, but depend on the question. For some kind of symbol like this, I try to do it in the shorter way to simplify it more so that you save your labor. So that is my teaching philosophy. Depend on the question, I will use a long way. If the question is so complicated and we have to break it down, I can use substitution u in there. But sometimes I would like just go straight forward and do it if the question is not so complicated. So it's up to your choice. And you probably, if you learn this from your teacher, you might see this is the way they taught you. And if you get used to with one way or another, just go ahead and choose whatever method you feel comfortable. But I want to prove to you that math only have one question, one answer, and that's how it works, right? So that is the beautiful of math. Nobody can argue. It's black and white. It's not like other language course or history or whatever you might have to, especially like political subject, like argument, right? We can twist around, we can argue a lot in our way of perspective, not in math. So anyway, let me get into the next question. So the next question will be, number 3. Let's say y equal e to the sine of x. A little bit of trigonometry, right? So y will be equal e to the sine x, which is the same it is, and derivative sine x, which is cos x. And usually you want to write cos x in front, but doesn't matter. That's how it's done. Okay. Question 4. Let's say if you have y equal e to 10 minus 1, like the inverse of 10x, right? So let's do the derivative. The derivative of e to the x is e to the x, so everything is stay the same, nothing change, right? 10 1x. However, we will take derivative of the inner function, which is 10x, inverse of 10x. And the formula of inverse of 10x is 1 times with 1 over 1 adding with x squared. So now we can put this in front, 1 over 1 plus x squared. And on the top, we can write e to 10 minus 1 to the x. So that's the answer. Okay, you can use substitution for u as well, but I don't think we need it, right? Okay, so let's do another one. Let's say number 5. If you have a function y equal x to the power of 2 e to the x. Okay, do you remember what rule we were supposed to use in here? This is like the product rule, right? We have two numbers multiplied together. So we have to use the product rule to differentiate this function. So y prime will be equal, keep the first one as the same, x to the power square, derivative of the second one, which is e to the x. Adding with, now keep the second one, e to the x, the same, derivative of the x squared, which is 2x. And that's it. That's you done. If you want to simplify a little bit, you can factor out the e to the x, right? So say e to the x factor out, and inside you have x squared adding with 2x. That's all you have to do, okay? So that is how the derivative of the natural